And good morning, everybody. We are live. Congratulations. You made it through the week. Another week of fantastic food safety, food quality, amazing foods and drinks that everyone enjoys, including Alan and myself. So if nobody says it to you guys, we're going to say it to you this week. You did a fantastic job, and we really appreciate all that you do. So if you're new to the chat, welcome. Pull up a chair. My name is Brian Armentrout, and I am the founder of the Food Leadership Group. And every week at this time, 8 a.m. Mountain Time on YouTube, LinkedIn, and Twitter, we live stream, and I bring an amazing food safety expert onto the chat with us. And we call it the chat for a reason, because what we do here is we have a conversation. And this is all about getting information to you. We are here to give you the answers that you need. And so with that, I'm going to inject, I love having this gentleman on. And if you're familiar with the chat, you know who this is. So this is Alan Saylor. And Alan is the managing partner at the Center for Food Safety and Regulatory Solutions. Mr. Saylor, how are you doing today?
I'm doing great. And Brian, thank you for letting me to come back. I really enjoy these chats.
Oh, you're one of my favorite guests, and your breadth of knowledge is just so impressive, and all of the things that you're able to bring to the table. And it's one of the things that I'm sure you're this way as well too, that we enjoy with what we do, is being able to share our knowledge and pass this on to the next generation of food safety professionals so that they can continue carrying that torch and making sure that everything works great.
I agree with you. I can tell you when I was starting out in my career, if it wouldn't have been for the mentorship of a number of people, and it doesn't mean you always incorporate, their information and advice, but to get as much information and advice as possible, why have to go through the effort of learning and in some cases discovering things after a lot of effort or making the same mistakes that others have done? Let's just go to the front of the class, and you do that by learning from others.
Absolutely. And it's amazing. Those little, you never know when they come. Those little nuggets of information, those little pieces. And one of those for me is this phrase, anything can be done for a price. And that comes courtesy of Mr. Phil Smith at Leprino Foods when I worked there. We were having a problem with a customer, and they wanted all this extra micro testing added onto the product, and it was completely unnecessary. This is when E. coli 0157 was first hitting, and everybody wanted E. coli 0157 testing, very expensive at the time. And he said, okay, fine. Anything can be done for a price, Brian. If that's what our customers want, we'll arrange that. Go out, get quotes for that testing, find out how much it's going to cost us, how long we need to hold the product, and then let them know what those additional costs are going to be for their product. And you know what? Once I explained the situation and said, we're testing for coliform. If there's no coliform, there's no E. coli, and not a one of them still wanted that testing. So that little chunk, I'm sure he just said it as an offhanded remark, and that has stuck with me to this day.
That is amazing. One of the same things, I wish I could remember who gave this advice to me. Maybe it was multiple people. It said, too many people do not know what they don't know. Ooh. And unfortunately, you have to think about that because it's not a great use of English language, but it is so true. And the fact is, if you know where your vulnerabilities are, you can do something about them. Yeah. But if you think you know everything or you know something and you don't, I can tell you the path to chaos is going to be pretty quick.
Yes, as our friend on the chat here, Austin, will attest to, the Dunning-Kruger effect is an incredible hindrance. People get a little bit of knowledge and then they think they're the expert and they start spouting off and they really don't know what they're talking about. A true expert, and this is always a good indicator for that, is, yeah, I know some stuff on these particular topics, but they also say, I don't know it all, right? They're willing to say, I don't know, and I'm learning these other things in these areas, and that's always that hallmark. And so as people are filing in here, good morning, Austin and Marin. Good to see you guys. Cortland, of course. And they're very happy to do that extra testing, of course. Yes. One of the things that we love to do here on the chat is let us know where you're at in the world. I am in Loveland, Colorado, where we are going through a normal spring. So we'll get some snow. It'll get cold. A few days later, it'll be back up to 70 degrees. And we're kind of going through that this weekend as well. It's going to be down to 45 degrees for a high tomorrow. So it'll be a chilly weekend for us. Where are you at, Alan?
I'm just outside of Washington, D.C., to the south of Northern Virginia, and we have been encountering about 2 weeks of slightly cooler. I mean, in fact, we actually had early this week, we had frost, and
Hmm,
that's unusual. So our temperatures are getting up into the high 50s during the day and the low 40s at night. But next week, the good old Virginia uh, weather pattern changes. We're going to be in the high 80s next week
nice.
and the low 60s or mid 60s. So yeah, that it's difficult.
So when in the DC area, when do the famous cherry are the cherry blossoms done, or when does that happen or did happen?
They are done. It's usually late March or early April, more likely early April. This
Mhm.
week they came almost 2 weeks early
Hmm.
because we had a very mild winter, and then of course what's happened since then? It's been quite cool. So
Yeah, that's a bummer. So one of the things that we do on the chat here as well to start off is everybody, please pick up your favorite beverage of choice and join Alan and I. Cheers.
here's
Very nice. So let's dive in, guys. One of the things that will drive you absolutely insane as a quality manager in a plant is this scenario. You, let's say you have a week off and you're out with your family and you're having a little bit of fun going to an amusement park or something like this. And then you come back to work that following Monday and you go to your office and you settle in and you do like we just did. You get a cup of coffee and you kind of do a little chitty chat and you decide to take a tour of the floor. And you go out there and you start walking around and all of a sudden you turn a corner and your eyes get big and you say, "What the hell is that?" And there's a brand new, or maybe not so new, piece of equipment jammed into a corner, and the maintenance guys are putting pipes on it, and there's electrical conduit everywhere, and it's just this gigantic mess. What is it? Yeah. And you start quizzing those guys, and they're just, doing the installation work. So you go up to the plant manager's office or the maintenance manager's office, and you're like, what is going on? And like, oh yeah, we got this screaming deal on this piece of whiz bang equipment that we're going to put into the process. What? And now, Alan, like it or not, that piece of equipment is yours. Congratulations.
wait a
Um,
minute, wait a minute. What do you mean yours? I didn't buy into this. I didn't sign off on it. Nobody asked me about it. Oh,
yeah.
that's right. It has impacts on food safety and quality. So yes, it is mine.
Yep. So now when that equipment is not cleanable or that equipment is not working correctly, or now to your point, Alan, Ryan, what are you going to do about this quality problem? Oh man, the number of times that's happened to me. Yeah.
I would, yeah, and you know the challenge is that it may have one of the nice benchmarks we have in the dairy industry is 3A. Okay,
Mhm.
so it has a 3A symbol on it. Well, if it is not a new piece of equipment, it may have complied with a 3A standard that was 4 years ago, 10 years ago, but it doesn't
Mhm.
comply with anything today. Can you still install it? Of course you can. The question is, can you make it operate so that the product will meet the quality and safety specifications, as you said? And it isn't just that piece of equipment. I like the way you set this up. They're connecting electrical, they're connecting water lines and other types of lines. And so they're integrating. And the big problem is not always just the piece of equipment. The piece of equipment may be fine, whether they told you ahead of time or not. It is the integration, the way it is put into the system. And there are too few people that really understand the problems that develop from integration. And integration today is not understood by regulatory very well. It is probably not looked at by the 3A people because they look at just a piece of equipment. And it probably isn't even understood by the industry that well. I mean,
Mhm.
engineers integrate a piece of equipment, of course. What about quality? How many people, how many of us have been trained in looking at the integration part? Are we going to get the right data from this information? Are we going to get the right flow rates through the equipment via a CIP system or this has been added on is different than what was there before. Um, yes, we went to college and we learned all that. The answer is no. I never learned it. Nobody ever taught me. You have to learn the stuff on the fly, or you have to learn it from others.
Yep, exactly. And as Cortland says here, that's why we need to do these things first. And that is exactly design equality. This is exactly what we're talking about here today. Now, Alan, you had referenced earlier something that everybody may not be familiar with. They should be, but maybe they're not. What is this 3A thing you talk about?
Ah, very good point. Well, 3A is an organization. It's nonprofit. It's been around. It's centered in the U.S. and it's been around probably for 50 years, if not more. Its counterpart in Europe is called eHedge. And while the organizations operate slightly differently, they actually have the same intent, and that is to make sure that the equipment is hygienically designed and engineered to be easily cleaned. Now, that's easy to say, and it's hard to do. In 3A, we have what are called CCEs, Certified Conformance Evaluators, that will go to the manufacturing site, look at the equipment, either as new equipment that will be soon moved into sales for the dairy industry or other industries, or they will actually go into 5-year renewals. So it is not, once you get a 3A symbol on a model of equipment, that it is done forever. You actually have 5-year renewals. This is all voluntary. It is not required. We have too many equipment organizations out there that design equipment that say it meets the intent of the 3A standard. There's no symbol. Who made that decision? Who understood that? I would suggest that unless you actually see the 3A stamp on the piece of equipment, do not assume that it meets 3A anything. And the key is it's hygienically cleaned.
Exactly. And so it's kind of like if you went to audit a potential supplier and said, okay, we require GFSI certification. Do you have that? And the customer, the supplier comes back and says, well, we have and they start dancing around and say, well, we have a SQF conforming system. No, right? I want to see the audit. I want to see the cert. I want to see the proof that you actually did what you say you're going to do. Now, part of this too with 3A, it's very widely used in the dairy industry. A lot of people out there say, well, I don't work in dairy. This doesn't really apply to me, right? But it can, right?
Well, it can. And what we're seeing is in the beverage industry, particularly in organizations, and I won't mention names, but some of the big soft drink manufacturers that produce not just soft drinks, but all kinds of beverages, including nutritional beverages, they use 3A. Is it required? Absolutely not. It's not required actually by industry anywhere, but there's a couple of places where it is required. And I think one of these places will surprise you. The first place is that if you are making a grade A dairy product of any kind, you either have to have equipment that meets 3A or meets the 2023 PMO. The other place is infant formula. This is something that I should have known because I've consulted in the infant formula industry for 8 or 10 years in a pretty intense way. It is required that companies that make infant formula, all their equipment must meet 3A standards if there is a standard that's applicable. And I bet that 95% of the people in the infant formula industry don't understand that, don't know it, and yet it's required.
Oh, interesting. And they've kind of paid the price for that.
Yeah, they are getting lots of attention by FDA. If you're in the infant formula industry, or even if you're supplying a major ingredient, and most of us in the dairy industry that do powdered products probably provide the infant formula industry with some ingredients. And so FDA is looking very intensely at that whole industry. And based on the reports I've seen in the last 5 or 6 months, FDA is not too happy with what they're finding.
No, I agree. That's what I've been seeing as well. And so these things are all interlocked. So part of what we're talking about here is you need to be, as a quality food safety professional working in the company, you need to be very proactive and you need to keep your ear to the ground. And as Cortland's talking about here, you need to be involved in that qualification process. You don't want to be on the back end because when you think about this, we all have different perspectives. And that's why we work in different departments. We're looking at it very differently. The engineering people are looking at it strictly from a design concept. will this fit in the plant? Does it have the right electrical requirements? Is it going to match up within our software and PLC systems? Is it going to do all these things from an engineering standpoint? And that's all they're looking at. They're not thinking about food safety. In their minds, and rightly so, the quality manager, the food safety manager needs to be thinking about these things. And if you don't interact and find out about these things, you're going to get surprised. The little scenario we had here at the beginning. And part of it for our first topic around this is with this equipment purchase and design is we tend to focus on high priced items. So that big fancy piece of equipment, that brand new filler that's going in the plant that costs $1 million, we look at those very intently, but you also need to look at other small things as well, don't you?
Well, that's so true. And this issue of validation verification of new equipment. I don't care if it's a valve or it's a $15 million filler. You need to do some review and you need to work with production. Production tends to know these things before we do.
Yeah.
And that's okay, as long as there's an understanding that you have to bring quality and safety into the picture and you have to bring them in early. Example
Right.
in my career, and this is maybe dating me a bit, but magnetic flow meter based system is pretty much standard today in most large dairy plants. But I can tell you that when I started my career, the first one, I was a state inspector and I was assigned to this plant. I was going to have the first magnetic flow meter in my state and probably one of the first 5 in the whole country.
Wow.
What was the regulation? There was almost no regulation. And so what do? Well, what I did, and this wasn't required, is I spent the next 38 hours once I got to that plant with the installation people. And one of the installation people was what I at that time thought was an old guy, which for me now would be a young guy. But it was an old guy that had been doing this in other beverage industries for 20 years. And
Mm.
I was attached to him like a flea to a dog. And from 2 a.m. to 4 a.m., I got schooling because nothing was happening at that time in magnetic flow meter based systems. And so I like, let's see, who was it? Duncan said something about we focus on the job training. Unfortunately, sometimes that's the only thing available. And so it is up to you to bring yourself up to speed. This idea that, well, nobody trained me, nobody told me about it, therefore it's not my fault, it's not my problem. I'm sorry, that doesn't cut it, at least not for me. If you want to really be in control, and that sometimes is a loose word, in control of your quality and food safety system in your facility, then you had better make the initiative to gather the information, to learn about it wherever you can. And sometimes the best way to do it, it's not, well, not the best way, the only way to do it, maybe while they're installing it. You
Yeah.
talk to the industry people. And eventually, if you gain their trust, they'll tell you things that maybe they shouldn't, that you can use to make sure it operates in your plant properly.
Exactly. And to the point we were mentioning earlier is you don't have to be a full-blown expert, Venus popping out of the clamshell. You start with the small stuff. Plants buy equipment all the time. So keep your ear to the ground. Make sure you are very close with the engineering and maintenance groups in your facility. Understand what your CapEx is, right? Because nothing gets purchased without CapEx. So there are line items in that budget that you need to be asking about in those plant meetings. Let's say that they buy a new conveyor belt.
Brian, I'm going to go off video for just a minute. Thank you.
Okay.
Keep going.
And let's see that they get a conveyor belt. And with that conveyor belt, how is it made? How are the links? Are they plastic links? Are they metal links? Is it a, God forbid, one of those old style canvas cloth type belts that are completely uncleanable? How is it moving the product? We know in the industry from experience that those plastic chain belts tend to, over time, get brittle and break. How old is this machine? Inspect those links within that system. If you're bringing in a used piece of equipment, this is incredibly important to understand these type of activities. This is where you start cutting your teeth. And this is what Alan was talking about here as well. This is where these things start out. you can start asking these questions. And again, how do I clean this belt? If you don't clean the belt, because how many times have you been in a plant and FDA is there doing an inspection and they're running their hands over the belts? They're using that as a proxy indicator to see how well you clean things. Because if you're not cleaning your belts, indirect food contact surfaces, maybe direct food contact surfaces, you're probably not cleaning other stuff as well. So belts, lines, what type, understand the different grades of stainless steel. Are they buying the correct grade of stainless steel? And there's all kinds of subcategories within those as well. Welcome back, Alan.
Well,
Can you hear
thank
me
you.
okay?
You're loud and clear. I hope I'm coming through okay. Good. I want to report. I want to respond to what you said, plus what Duncan has put in about the extent of the unknowns. The idea of knowing what you don't know is really important. But then it begs the next question. Okay, so I don't know. How do I move into the know? And that's what we're talking about here.
Yeah.
So when we're talking about equipment integration, and well, where do you get this information from? Well, believe it or not, FDA does have training sessions for their people. Oh, great. I'm not FDA. So what does that do for me? Well, you can get the manuals. The other problem is that if you remember in 2017, FDA made a commitment to change its field staff organization so it was specific to food sectors. So now only dairy trained inspectors should be in dairy plants. What's that got to do with us? Well, I can learn from them. Except you know what's happening? I talked to a dairy person that's with one of the largest dairy companies in the United States early this week. He was in his dairy plant in the southeast part of the United States, and an FDA person happened to be there.
Mm.
He was a seafood inspector. He was an expert in seafood. Well, wait a minute. You just said that we have reorganized the field so that there's only dairy people. Well, that would be great. So my point of this is, can you learn from regulatory? Yes, you may, if they have the right knowledge. The problem is that is usually the reverse. We're probably more likely to train them. So where do you get the information? The beauty is the internet. The beauty is there are companies and there are not necessarily salespeople, but technical people in these companies that you can talk to gain this information. You can go to the 3A meetings and learn more about equipment and hygienic design. I was giving a presentation at Process Expo last October in Chicago. And after all of the presentation and all the questions were finished, there's a gentleman came up to me and he had a display across the aisle outside of the meeting room, but apparently my voice carried. And he said, I want to carry the information you said. And I said, what is that? He said, all my engineers, you said all the engineers of design equipment should be required to be in a dairy plant where their equipment is installed for a week after the equipment is installed. And I said, well, you're welcome to use it. I think that's very true. Because number one, you could train the quality and safety people about how this equipment is supposed to work. And number two, they could train you about why this equipment is going to be a problem for them. So just observations.
Fantastic. And there's all these amazing resources out there. I took a training course from Ecolab on sanitation. One of the best courses I ever took, showing the why and the how of how cleaning works and what the different steps are for cleaning. And as Neil Bogart says, you can't clean something that has dirt on it, right? You have to remove those things first. And learning from those sources is amazing, and being able to do that. So sanitation companies, chemical companies, packaging companies, Tetra, right? It makes the aseptic packaging, has a fantastic aseptic facility pilot plant in Denton, Texas, where if you're a big enough customer, you can go there and run products on their lines and see how they perform. Just think of the information you can get from those people. You have to be able to look at it from those perspectives. And to your point, I think really, Alan, what you're saying, you have to be curious and show people, this is human nature. If you show an interest in what somebody is doing, man, they love to talk about themselves. So just showing an interest and getting out there on the floor and engaging with those install crews. Because if you think about it too, Alan, they're no different than, let's say, a SQF auditor. They're on the road all the time. Nobody's really happy to see them. They want them in and out there, out of that plant as quickly as possible so they can start producing again. If you're an installation engineer working for a product, a design company who's putting in equipment, you're on the road all the time. You're very happy for human companionship, and especially someone who is interested in what they're doing.
That's great. And just to point out, I hope people, as we are talking, are looking at the chat. Cortland pointed out a couple of things that were interesting.
Yeah.
Stennis offers great training. Brian, I thought that you had some great points. The 3A annual meeting will be in Chicago from May 6th to 9th, really May 7th through 9th for most of us. And you can get some really good information. I also saw Cortland put up there, well, and I don't think this is exactly what she said, but I'm going to change it into suit me. And that is that, well, if you have good DQ, IQ, OQ, and PQ programs, maybe you're not going to get into trouble. Maybe you're not going to have problems. And the answer is that could be. But everything is dependent upon the human factor. You can have great programs, you can have training, you can have knowledgeable people. It is all about implementation. So I like the two I's that we are focusing on today: implementation and integration. We really have some issues in the industry. And we're not the only food sector, but integration and implementation are things we need to work on.
Right. And if you're making a major purchase of equipment, so let's say a brand new filler, there's two levels to this at a high stage. And this is why you need to cut your teeth on the smaller stuff. There's what's known as a FAT and an SAT. And you see these terms bandied about quite a bit. What do those two acronyms mean, Alan?
Well, I'm going to let you tell me what they mean, because I'm not absolutely certain. So please go ahead, and then I'll add my comments.
I'm sorry. So the first is factory acceptance testing. So let's say that I am buying a brand new filler from Bosch, and this sucker is going to cost me $5 million. Of course, the company is going to be paying very close attention to this. Your engineering group is going to be looking at it, all kinds of different people. You need to be doing that too. So what happens is you will send a team, and Bosch is in Germany, and we used to do this at Whitewave. You send a team of people over to the factory where they actually make the machine. They set it up, they run it, they put it through its paces right there. This is your first swipe at whether or not this machine is meeting the requirements that are set up for it, FAT. But those requirements generally are speed, flow through, throughput, downtime, software integrate, all of these type of engineering type questions. They aren't running product through it. They're running it, like a surrogate type product. They're running hot water or things like this. And this is that first pass to see if it's meeting the requirements that the engineers built into the contract. You need to be putting requirements in there too. And that 3A link, I'll put the link to their site here at the end of our chat today.
Okay.
Critical. You need to be inserting those quality requirements as well. It has to be cleanable, for example. Right? It has to be accessible. All of these type of things. And this is your first pass at looking at those type of activities. So if it meets all those criteria, then it is sent to the plant and it's installed. And so now if you're dealing with low acid canned food regulations or aseptic manufacturing or things like this, now you've got even more things that need to be met for those requirements. And the SAT then is the site acceptance test. So they crate that sucker up, ship it across the ocean, bring it to your plant. To your point earlier, Alan, all those engineers and all these things from Bosch or whatever company it is are there in your plant setting all this stuff up. Now you have to do the site acceptance test. And that means, does it work as it is intended? But to your point, and this is one of our main topics here with our conversation, is it integrated? That's part of your job, is to help figure that out. And they're only looking at it from those engineering criteria. You need to have language in those contracts that it needs to be acceptable for food safety as well. Because once it's signed off and that the company that you're working for says, yes, this meets our site acceptance, and they sign the dotted line and they pay the money, it's yours.
That's very true. And an example of this FAT versus SAT is experience I had when I was still in the consulting business. Well, I still am in the consulting business, but I was working for a consulting company. And this company in France wanted to take a plant, the equipment from that plant in France, shut it down because the quality of the milk and the milk supply was so much better in the US. They had a greenfield facility. Essentially, it was a warehouse that they bought, and they were going to move this equipment to the United States. And somebody, fortunately, they had a U.S. senior engineer. That is very unusual. I'm not talking about France or any other country. It's unusual in a large international dairy corporation to have somebody outside of that, where that country is or that company is based, as in a senior position. And he said, it isn't that simple. And after a while, there was at least an agreement that let's get an objective third party. Let's get somebody from the US that understands the requirements. And they did. They sent that person, I was in charge, but I was not over there, to look at the equipment. And when they got done, the report was not very favorable about this equipment meeting the US requirements for cleanability, for integration, for lots of other things. And therefore and that was not our intent, was to stop it, but it supported what this American senior engineer was trying to get across. And so we don't have to have equipment coming from outside the US. It certainly can be designed in the US and still have these challenging problems with, and let's look at the regulatory aspect. That's where I have a little more background. And that is that FDA requires that under 21 CFR 117, the preventive controls for human foods is my short version of what that regulation says. Under subsection C, it talks about validation of preventive controls. And what do you have to validate? Well, it doesn't absolutely say you have to validate the sanitation, but you would be foolish not to do that because of allergen issues, because of cleaning issues. And so I think that this issue of new equipment and integration really can hurt you, because when FDA or a state inspector comes on site, who do they usually pair with? It's the quality team. And they also hold you responsible because you're probably the PCQI. You sign off on everything. So you really have a burden. Maybe you didn't think you signed on for it, but you have it.
That's a really, really good point. The preventive control qualified individual is responsible for the food safety plan and the safety of the food. That includes what we're talking about. You cannot delegate that responsibility. You're the one who's going to be signing off at the end. And those different groups are looking at it different ways. Part of this as well is whenever you put a new piece of equipment into a plant, Alan, and it's going to impact the flow. It can be positive, it can be negative, but one of the rules in a production facility is always you have a bottleneck. Just you need to figure out where it is. So for example, let's say your bottleneck in your plant is filling. And so you say, okay, my manager says, I'm going to go out and buy a new filler, this whiz bang super fast filler that's going to be twice the speed of the old filler. That'll solve our problems. So you buy it and you install it. Well, guess what? The bottleneck moved now from filling to processing, because now your processor can't keep up with this new whiz bang filler. So now all you've done is moved that to a new point in the process. You need to anticipate that. You need to figure out what those bottlenecks are, because if you aren't, your efficiency in your facility you think is going to improve, and it's really not. And you need to understand those bottlenecks in your process.
And it's not a problem, Brian, because I've got 2 CIP systems. I've got one on the raw side that isn't even close to being at capacity. I've got my processing CIP that is pretty much at capacity. So you know what? I will just divert and some piping, and I'll use my raw side CIP system to clean this new equipment, because you're right. Or maybe I divert it to clean some of the existing equipment, and then I'll use the processing CIP system, which is at capacity. I'll take some of that capacity, put it on the raw side, so that I can meet my capacity needs on the pasteurized or processing side with this new equipment. And you think, well, how could that happen? Anybody, that's basic 101 food hygiene. I can tell you that I was in a plant not more than a month and a half ago, not in this country, but in a very advanced dairy processing country, where that was their solution, is that as their processing side capacity expanded, instead of marching in tune and increasing the CIP capacity of the processing side, they had underutilized raw side capacity on CIP. So they just diverted and cleaned some of the past process equipment with the raw side. And you think, how can that happen? Well, it seemed like a good engineering solution. All the engineering figures worked. They didn't talk to quality. And by the way, the quality people were very good. They didn't know it. They had no idea until we started asking questions. So,
Yeah.
is this going to happen in your plant? I hope not. But make sure, and to your point, I think you led off with this, be very close with maintenance. And I know there's this change, SQF and all these GFSI systems require that there is a change management process. I think it is one of those that when we run out of time, or we get short of time, we'll get around to it. We'll get around to notifying. And that is an area that we sometimes, that's where we get hurt, is because it isn't that important. I'll get around to it. And it never gets done. So the proper people are not notified. And
Yeah.
then you have just created a massive problem versus a small problem.
Yeah. And those utilities are so important. There's only so much water that can come into the plant. There's only so much cooling capacity that plant can generate. These are limited, finite resources that need to supply the process, and you need to understand those. So we've been talking a lot about new equipment for this as well, but let's not forget about what we open with as well is used equipment. Oh, such a risk. There are websites out there. I've been to these sites and I've purchased equipment on these sites where you can buy used equipment. So a shut down dairy plant in Wisconsin auctions off all their equipment and they put them on these websites for people to buy. Okay. What if you work in an industry that doesn't have a dairy allergen? And now you're buying this equipment, most times sight unseen, off the internet. They load it on a flatbed, send it out to your plant. You have no idea what's been through that machine. Worse yet, to your point, Alan, international companies. So you're an American company that's a subsidiary of a foreign company who doesn't necessarily have these standards that we're talking about. And the parent company says, we're sending you equipment. We shut down some plants and we had some old stuff laying around, and congratulations, it's yours now. You have no say. In that position, it's yes, sir. And off the equipment comes. And now you have to mitigate that risk somehow.
Yeah, it's an interesting conundrum of who's responsible, when did it happen, how did it happen, and sometimes this will not appear initially.
Mhm.
This will only appear after a period of time running where you have generally in failure, and this is not getting away from our topic, Brian, but I think this is good in our discussion, is that when we have quality and safety failures, we usually don't find a single root cause. It is usually multiple root causes, which is very confounding. It's lovely if we use the HACCP approach to say, okay, now we found the root cause. We're all good. We're all happy. We can sleep at night again for a while anyway. And I'll tell you what, it is rare, at least in my experience, that there is a single root cause. It is multiple, and it drives you crazy because when you solved one, and I'm not in the criminal field at all, but it's like you found your suspect, you put that person in jail, and the crimes keep continuing.
Yeah.
And this is what we tend to find so much in our world. So do not be too egotistical that you found the solution. You may have. but always look for multiple causes, because usually that's what will trigger a failure.
Right. And so, yeah, Duncan and Cortland are giving me grief here on equipment purchases. No. So what we're talking about here, I did go through this on those equipment purchases. So they ended up being good purchases on that side. So
Well,
with
can
that,
I say one thing? Can I say one thing about used equipment? I apologize, but to your point, we reuse equipment.
yeah.
It's just a reality, whether it's in the dairy industry or not. Um, I can share with you an experience. There was a new plant going to be built in a state that had very few dairy plants, and therefore this was really needed to cut
Mhm.
down supply costs and everything. So this was going to be an initiative by a non-dairy company to build a dairy plant, and they hired credible people to build this greenfield facility. Then they decided, because of the cost overruns, that they were going to use used equipment. And there's good used equipment out there, but there's
Mhm.
also very bad. Once they got the equipment installed and they started running, their quality was absolutely, they could not move the product out of the warehouse because of product. This is a fluid milk product. So it wasn't that it was unsafe, it was that the quality, shelf life, you couldn't get a shelf life beyond 10 days. Well, 10 days
Ooh.
when I was starting out was, you get 10 days? How did you do that? That's great. 10 days today, and you're not going to survive for any time. And eventually, this company declared bankruptcy. There was a lawsuit. And the lawsuit, when we sent our experts in to look at the equipment, whoever accepted that equipment um, clearly had no understanding of what the basics of equipment design and hygiene needed to be. This equipment had poor welds, and I think it came from the used equipment manufacturer. But I just have to, the epilogue to that is, you know how the lawsuit came out?
Mm.
The dairy plant and the investors lost because they didn't do their due diligence in checking the equipment before they put it in line and started making product. And as a result, they could not absolutely convince the judge and jury that they were not the problem, instead of the equipment manufacturer.
Right. You're responsible. You are responsible. So it's like Duncan says here, just imagine, right? You have this piece of mystery equipment and trying to figure out what type of allergens have been through it and what type of allergen risk. Because when you think about that, all you need is just a little bit of allergen. It's a teeny tiny little bit from a prior product, let's say peanuts that were ran through that equipment, and you're running dairy products and it comes loose during the process. You had no idea it was there. And all of a sudden you have a recall because you didn't do your due diligence on that equipment. And the age of the equipment, to your point, Alan, yeah, it may be 3A, but if it was 3A from 1950, well, that's a very different, very different standard. And so we put a list here together of some of those integration points, guys. So think about these and write these down. So we've been talking here about footprint and access. So the engineering guys are looking at that piece of equipment and saying, "Oh, I've got a 10 by 10 space over here in this corner. I can just throw it over there." And they do. And now you look at it, and your sanitation manager looks at it, and you're like, how do I can't even get to the back of this machine." And the maintenance guys are saying, "Well, I can't even get to the pump on the back of this. How am I supposed to change the bearings?" All of these type of things, it's sitting flat on the floor. Things are going to pool up underneath the machine and grow. There's no drains in this area. There's no access to sanitation lines. There's no foaming equipment in this area. This area is not part of our positive air pressure in this room. Flow. How are the people moving around this equipment? So if you have an operator, is he having to go running back and forth to this piece of machinery? Footprint and access is critical.
I agree. And you've got me thinking a little back to 3A, because there was a question early on, well, where do we get this information? Where do we get this training? You suggest some things. We had a chat person suggest some things. Ecolab was mentioned. But I'm going to tell you, when it comes to what are the basics for any piece of equipment, I don't care if it's a filler, if it's a valve, it's a pump, if it's a vat, there are some basics. And where can you get these basics? Because I was taught about microbiology, I was taught a little about chemistry, um, and I was taught about how to write food safety plans and how to do internal auditing. But when it comes to a piece of equipment, I mean, if it's ugly, I recognize it, but I really don't know enough about what should I be looking for. My strong suggestion is in 3A, there is the general standard 00-00, or it might be 01 or 02 now. It may cost you $50. It may cost you $100. Get it. Do you know what that standard has? It has the basics of what all equipment should be to be designed to meet hygienic standards. And so I cannot encourage you enough. Yes, it's not free. I apologize. I could write a paper probably within a half an hour that could summarize the bullets of what you need to look for. Where are the weaknesses in equipment where you're going to get buildups, where you can't get the allergen out, you can't get the micro, you're going to create a harborage area, things like that. And there are also at the 3A meeting, believe it or not, we're going to have somebody from FDA talking about equipment that has no 3A standard and what drives them crazy. Because the 3A standard, that means I can do whatever I want. No, if you go to the general standard, those basic criteria or performance requirements for all equipment, they apply. A vacuum breaker, for instance, a vacuum breaker, most of them nowadays say they're CIP, but you know what? When FDA and state inspectors take those things apart, and I hope you do as a quality person, about 50% of the time, they're not clean and they stick. And if they stick and they are not operable, that's a 15-point loss. And a 15-point loss on a grade A inspection means you have failed, you've lost your grade A status.
Ooh.
How are you going to explain that? Well, it wasn't my fault. It was purchasing that bought the wrong piece of equipment. It was engineering that installed it improperly and didn't put it on a short enough leg. That, unfortunately, is probably not going to save you, and it may not save your job.
Exactly. And so part of this is, again, one of the key things that we talk about here on the Food Safety Chat, Alan, is you don't have to be the expert in everything. I'm not the expert. What I know is people who are the experts. So, for example, the gentleman joining me on the chat today. And I can ask questions. Part of this, too, is understanding with equipment. Equipment is a conglomeration of different things: pumps, valves, pipes, belts, all these type of things. And once you start understanding the pieces, then you can start understanding the equipment. So talk with your maintenance team, talk with your engineering team. Say, hey guys, can you explain to me the different type of pumps that we use in this plant? Oh, sure. We have positive displacement pumps, we have diaphragm pumps, we have centrifugal pumps. What do those things do? What is the difference? And they will be more than happy to explain those to you. Each of those pumps are used in different applications. And those different types of pumps have different cleaning requirements and different maintenance requirements.
Brian, and we just had a late joiner, so we are talking about equipment and equipment integration and hygienically designed equipment. When you and I prepared for this, you gave an example I thought was really, really interesting. I think the rest of the group would like to hear about. And this was, without mentioning names, this was about a plant that had been designed to be very flexible. So it had lots of valve banks, and valve banks simply are, 4x4, 16 valves, and you can go through one of them, you can go through all of them, you can go through some of them, and you can go wherever you want to go in the plant. Can you tell the rest of us a little about what your experience was when your company took possession of this facility that had all this amazing flexibility?
Absolutely. That was a great point. So plants are designed for a purpose. And this plant in particular was a dairy plant, a very large dairy plant that was designed probably in the 70s. At that point in time, plant design was, I want to be able to produce raw materials, produce different types of fluid products, and be able to send them through any processor I want, any filling line I want, any packaging line I want, because I want maximum flexibility within my plant to be able to produce all these different things. Fantastic. I'm able, as a plant manager, to succeed and produce all these crazy products for the marketing team. Well, that's great if you have one allergen. Now, if you have multiple allergens, you have a gigantic problem. Because to Alan's point earlier, those valves, all you need is one valve. And if you've been in a plant, you see how many valves are around in plants. One sticky valve that's not quite closing correctly, or one improper PLC, one improper computer system. And now all of a sudden you're sending a allergen to another product that was unintended. Once you identify these things, now all of a sudden you have to go back and redesign that entire plant. And you have to remove that. And you have to, if you have multiple allergens, you have to redesign that plant to separate, completely separate physically those different products. So there's absolutely zero chance. And that's extremely expensive.
Well, and the human factor too. We're not psychologists, we're not sociologists. I was forced during my engineering curriculum to take those courses, and it was fine. But to me, that was not a profession. That was something else. But I can't emphasize enough the human factor. And this is again something you had mentioned about the fact that we have automated these plants. And maybe at some point, AI will become advanced enough. So just like today, we have cars and vehicles that can drive themselves, which, by the way, my vehicle is never going to drive itself. I'm sorry. But where AI can take over control of operating the facility. So when there are certain issues, then the AI system kicks in and makes decisions and opens valves, starts pumps, opens valves that go to tanks and things like that. But you had said something to me about you had an experience where an operator had hit the wrong button. And maybe they were close by, maybe they weren't, maybe they're marked similarly, maybe they're both the same color, and then quickly understood the mistake and hit the correct button.
Yeah.
And tell about that, because I think it's all about the human factor and integration and equipment.
Yeah. So, and really that was the genesis of this redesign of that plant, because we thought we had it all figured out. And it was just that operator hit the wrong transfer button and went, oops, and then quick switched it back to the correct one. Just like that. Did that operator tell anyone they did that? Nope. Should they have? 100%. Yes. Right. So now we had an improper allergen mixed in product. We didn't know about it, and it resulted in a recall, right? A very expensive recall. And those computer processes we're talking about, that's one of those integration pieces that you need to be looking at is how do we lock things out? How do we block these? And to Cortland's point here, because this is a really important one, is dead legs. Dead legs are pipes that don't go anywhere. And what is sitting in that pipe, right? Old product. The sanitation, the CIP systems cannot flush this out because there's no flow through that pipe. So it just sits there and gets right? Nasty. And you'll have these hits in your micro and you have no idea why, right? You need to be super aware of dead legs. So thank you for that, Cortland. That's a good one. Whoa, time's flying here. We need to look at some other ideas here. So we're talking about software. Software is always advancing. Is that brand new whiz-bang filler that you bought compatible from a software standpoint with the old 1980s equipment? Probably not. How are you going to marry those things up? Overall system monitoring. How are you setting it up within your software systems with the maintenance and engineering groups for the control of those different systems? How are you tagging that equipment so you know where everything is? This should all be done during the install. Parts and supplies. Ooh, I'm sure there's lots of people on this call, Alan, that remember during COVID, if you had replacements parts, because we moved to just in time on a lot of parts inventories. So now all of a sudden that specialized part for that new piece of equipment that you have that comes from Germany is not available. What do you do now? It's well past its service window. Odds are it's breaking down, things are going on, and you can't replace it because you don't have the parts. Huge. And to your point, yeah. I'm sorry, go ahead.
No, I was going to say go ahead and then I'll add mine.
Yeah. So any other points around that integration piece of it before I move on?
Well, there is, and it is simple simple. In other words, my point is this, is that we can do some pretty amazing things with integrating equipment and controls and electronics and the cleaning systems, and we can put it into a very nice software program. Um, but does anybody understand it? Let me give you two examples. One that was at the beginning of my career, one that was 2 months ago. One at the beginning of my career was that we took an advanced processing system that had not really been used that much, and there were two sister plants. The one plant manager loved it and said, "Hey, we're going to put it in." And the other plant manager, which was younger, by the way,
Mm.
said, "No, we're not going to put it in. We're going to keep our system where we understand it. And yes, we're going to make advances, but we're not going to put in this cutting edge, state of the art control system." And you come back 2 years later, the plant that put in the advanced state of the art control system couldn't quite ever get it to operate the way it was supposed to, and it was shut down. The one that stayed simple with the younger plant manager, which I would say, well, they would just get left behind in the technology advance, is operating to this day. And it's not that they didn't adopt certain advancements, but they were very cautious. Okay, that
Mm.
was meant at the beginning of my career. Let me give you an example of 2 months ago. I was in China. I was working and I had the pleasure of talking to a student at a university on food safety. I was teaching a course there in China, and his parents owned two facilities, two food facilities. And he was bringing in a company that was out of Canada, and they were going to install AI programming into their software so that they had less human intervention into the processing systems, because he's a young guy, right? He knows about AI, or he understands about it, or he hears about it. So, the parents, they're just old and outdated. And guess what we can do? And after he gave me some background, he said, "What do you think, Mr. Sailor?" I was like, being called Mr. Sailor. But anyway, the point was, my advice was run, run as fast as you can away. Because if you don't understand everything about it, we understand the concepts of AI, but what does it do as far as your system? What does it do? Is it like the cars that and vehicles that drive with AI? And now we're finding that there are not now, we've known for a long time, it isn't quite a perfect system yet.
Mhm.
So my caution is, as you were looking to these new technologies, if you do not understand them as a quality person, don't allow engineering to buffalo you into saying, well, this is the latest technology and everybody's doing it. Ask them, do they understand? They understand what the impact will be. Do they understand how the program, what are the defaults? What are the corrective actions that will happen without any human intervention? If they do not understand that, and my approach is always to avoid confrontation by using the term no. You
Mhm.
instead ask questions, and you ask enough questions till it becomes apparent that they do not understand the piece of equipment, the integration system, the software that's going to operate it. This is the way that you manage things.
Fantastic point. And that's a great way, I think, to bring our chat back up to the 30,000-foot level. Don't be the guinea pig. Right? They want to test their new stuff in your plant. Don't go through that pain. So really, I think, and this is a good point to bring up for our closure as well, Alan, is always remember this is all based around the contract and somebody getting paid. That's the point in time where you have the most control. You need to build language into the contracts that say, okay, fine, this needs to meet these certain performance criteria that the engineering guys have, but it also needs to meet the sanitation requirements, the software requirements, all the other supporting requirements to Cortland's point here, the validation of these processes, and food safety needs to sign off on this before you get paid. Because once that check is written and the acceptance is done, you're stuck with it. So make sure you have that up front. Any other closing thoughts, Alan?
No, I just love some of the comments from the people
Oh
that
yeah.
are with us today, both Courtney, it's not to exclude anybody, but Duncan must be an engineer because he comes back with some of the comments, and I really like that. And I have
Yeah.
an engineering background, but my passion and my profession for the last 40 years has been food safety. So the fact that you come from a different, maybe you were a journalist, it doesn't matter what your degree is in, use that information and use that approach to improve what you are going to do as far as food quality and safety. And I know there was a comment that, well, really dairy is at the top of the food safety sector. So why don't we talk about the others? Well, let the others figure it out. Let us just make sure we're doing what we're supposed to.
Absolutely. Fantastic point. So with that, guys, let me stick here in the comments here before we close. So this is chat number, believe it or not, Alan, 175. We've done 175 of these chats. And I've collected all of these chats into this link. I've created an online database with all of this information, because part of the problem is investing an hour every week is a significant investment. And we recognize that and appreciate everybody being here for this. But sometimes you want access remotely. So if you want to listen to it in your car, you can download it from this site. If you want to rewatch it, I also include the notes and support materials associated with these chats as well. So you get access to all that stuff. So go ahead and check that out and see if that's of interest to you. Hopefully that is. So with that, wow, what a fantastic chat. Thank you, Alan, and just amazing. And to your point, thank you, all of our amazing, you're not really even guests, right? You're participants in this chat. And we really, really appreciate that. And we appreciate all that you do. So with that, we're going to bring our chat to a close for this week. And thank you to everyone for doing this. In the meantime, enjoy your weekend. Have a great time. And we'll start back on Monday. Hopefully there's no new equipment in your plant over the weekend. And we'll see you back here next Friday at the same time, 8 a.m., 10 a.m. Eastern, for the next food safety chat. So have a great time. Thanks again, Alan. Thanks, everybody.
Thanks for the opportunity, Brian. Take care, everyone.